A radioactive element has a half-life of 11 years. In other words, every 11 years it goes by half. If 20 grams of the element is remaining after 25 years, what was the initial mass in grams of the element? So this is what I'm going to do. I'm going to write out the half-life formula that I know how. So this is an exponential form formula. Okay, A is always what you start out with. B is going to be your growth factor, and X in this case is going to be time. So do I know what we start out with right away? No, but what I do know is we end with 20. I don't know my initial amount. I do know that I'm taking a half of it every 11 years. So how do I show every 11 years? By doing X over 11. Now, I care about what happens at 25. So I'm going to rewrite this to be 20 equals A times a half to the 25 over 11. So this is how I'm going to handle this problem, because now I need a calculator to take over. I'm going to find 1/2 to the 25 over 11, get some number, and 20 divided by that number is going to get me my A. So let's see what happens. So now I'm at the point where I really can't do much without a calculator. So I have two calculations that I need to do. First thing I need to do is I need to figure out what 1/2 to the 25 over 11th power is. So I'm typing that out. If I can just type and not make a little typo, 25 over 11. It's going to give me that number right there. Now I'm going to take 20 and divide that number from 20. So I can divide that number if I want to by hitting second and then that little negative symbol there. And what that does is that uses that whole number so I get more accurate of an answer, which gives me that guy right there. And darned if that isn't awfully close to C, which it is. So that's my answer. So the A I got is 96.6, I think it was 665 or something like that. So that gives me C. Close enough. I mean, you're not looking at exact when we're dealing with some rounding error, but no, that's my guy, and I'm sticking with C. C is the answer. C it is. C. C means yes.